Ah, excellent. I see we've got incoming news from our friend in Sith Ifrican. So these flat earthers have been pretty busy lately. We've got Mitchell from Australia, who's been Mitch slapped several times. Check out my Mitch Hiker's Guide to the Fallacy series. We got Quantum Eraser randomly pulling quotes without reading entire sentences or paragraphs. We got Nathan Oakley getting all shouty and totally strawmanning everyone with his hand on the mute button. We got Dense Man Rising. Oh, sorry, did I say it out loud? I mean 10th Man Rising, totally failing to understand what trilateration is. And now, another has joined the fray, Flatzoid FE. So my little Sith Ifrican friend, take it away. In recent weeks, flat earthers have been in all of a kerfuffle about sextants. They seem to think that a sextant proves the earth is flat and that it can't possibly be a globe. Well, thank you. It's kind of nice to get applause. If you're going to try and debunk sextants that absolutely require the earth to be a globe in order to work... Why is he laughing? Why are you laughing? That when you're doing celestial navigation with a sextant, you're not using triangulation. And why is she laughing? Why is she laughing? Doing celestial navigation with a sextant, you're not using triangulation. Well, I made several statements about sextants and celestial navigation, triangulation, trilateration, every one of which I stand by 100%. So I don't know why you've got all this inane laughter.
Laugh it up, fuzzball.
In fact, when flat earthers put out videos, this is the usual response.
Oh, isn't that funny?
Come on, it's about time you got on with it, Flatzoid. What is the nub of your gist?
What did he say?
What has trilateration got to do with using a sextant? Well, Flatzoid, if you're going to carry out celestial navigation, it has everything to do with the sextant. Aha, the difference between triangulation and trilateration.
I don't know about that, but I do know that I love fluffy little kittens.
Well, Flatzoid, I'm holding out less hope of you understanding that than I have of receiving a phone call from Kylie Minogue demanding that I become her plaything.
What is triangulation?
A good question, and one that has been much on my mind in recent weeks.
Mr. Sensible, you do understand. You have a point. You have the luminary, which is the sun here.
Ah, Flat Earther's measuring device of choice. A crayon.
And you have the zenith, which is the GP. This creates a triangle.
Well, two things, Flatzoid, spring to mind. Firstly, the zenith is not the GP. The GP is the point on Earth directly below your zenith. Secondly, we don't create triangles. But let's run with it. We'll assume you're flat Earth. You show us triangulation.
With a sextant, you are using triangulations. You have an A, B, and C. The 90 degree from the zenith and your angle towards the luminary. Triangulation.
Flatzoid, because you have a triangle on the screen doesn't mean it's triangulation. With triangulation, you need angles to several known positions. All you have on the screen is a triangle. With this, you're not even solving a triangle. Let's see what information you've got. You've got your viewing angle, the angle of the star above your horizontal at A. Let's say it's 45 degrees. You have B, the position of the star. Directly below it, you have its GP at C, which is 90 degrees to the horizontal. So what have we got? We've got 45 degrees to the star, 90 degrees at point C. We don't know how far it is from A to C because that's the distance we're trying to work out. We don't know how far it is from A to B to the star. We don't know how far it is from B to C, the height of the star. So basically we have no sides of the triangle. So go ahead, solve that triangle and give us length A to C. You can't. You do not have the information. That is a total fail. And even if you did, that's not triangulation. That's just solving one triangle. So what is triangulation then, Flatzoid? Well, that's when you don't know your distance to various known positions, but you know the angles to them. So in this case, we're somewhere in the wilderness. We sight a mountain, landmark 1. We read its bearing. We then take our map, find landmark 1 and draw that bearing line on it. We are somewhere along that line. Then we do that a couple more times. We mark up all the bearings on the map. Where they cross is your position. In this case, there's a little triangle because of error, so we're somewhere in that little triangle. That is triangulation.
What is trilateration?
Trilateration, another good question that has also been much on my mind in recent weeks.
Well, first of all, Mr. Sensible, you would actually need a receiver.
Flatzoid, you've been listening to too much 10th Man, haven't you? Yes, you can use signals and receivers to trilaterate, such as with GPS. But you can trilaterate using distances however they were obtained. You do not have to use any sort of electronic broadcast.
And you would need some kind of tower sending out a signal. This tower sends out a signal that moves with a certain radii.
Flatzoid, it doesn't move with a certain radii. The signal expands outwards in a circle. The radius is increasing all the time.
This circle of equal altitude will ping as soon as it hits your receiver.
Now, I don't wish to appear churlish, but one does feel a churl coming on. Flatzoid, I think you perhaps have little idea of the things of which you speak. A circle of equal altitude is the circle around the GP of a star where that star appears at the same altitude, equal altitude. It has nothing to do with radio signals.
A sextant does not have a receiver.
Yay, he got something right.
Therefore, it's not trilateration.
Oh, bugger.
Now, you have 3 towers emitting signals.
Then shalt thou count to 3.
They move towards the receiver. As soon as they hit the receiver, you will receive a ping. Let's take a gander. There they're moving out. Ping! Ping, ping! And that is how you work out with trilateration, the distance from the emitting towers.
Well, I have to give you that, Flatzoid. That is trilateration. It is one form of trilateration. Those signals could be coming from towers. They could be coming from GPS satellites. With both of those, the timings of the signals give you the distance. You draw circles around their known positions and trilaterate. But you can use any method to get those distances. In my previous video, I did a spoof example where I phoned 3 people and they told me how far away I was from their known positions. And I could trilaterate. I could use some sort of laser range finding measuring device to measure 3 known points. Get the distances, trilaterate. Or I could use a sextant. Take readings from 3 stars to get their distances in nautical miles, mark their GPs up on a map, draw 3 circles around them, and trilaterate. With celestial navigation using a sextant, we're not triangulating. Hell, we're not even calculating and solving a triangle. Star's light comes in parallel rays. If we're the observer stood at the top of the Earth there, we take a sextant reading to that star. We're measuring H, the angle of that star above the horizontal. You could use the horizon and adjust for dip and refraction, but there are other means to establish a horizontal. So you calculated H. You deduct that from 90 to see Z, the angle of that star from your zenith. Let's say that's 70 degrees. Multiply it by 60 gives you 4,200 nautical miles from the GP. That's minutes of arc around a curve. It makes me laugh, all you flat earthers talking about sextants and happily taking a star's angle from zenith and multiplying it by 60 and coming up with a distance in nautical miles, when nautical miles by definition is distance around a circle. 1 nautical mile is 1 arc minute. 60 nautical miles is 1 degree. Now that 1 degree, that's 60 nautical miles, is about 69 miles. So what happens if you multiply 69 miles by 360 degrees? Yeah, you get a distance of 24,840 miles, which by some strange coincidence happens to be the circumference of the globe Earth. So take that 24,840, divide it by pi, giving you 7,910 miles. Divide it by 2, giving you 3,955. Yep, every time one of you gimboids uses nautical miles converted to miles, you are proving the circumference and therefore the radius of the Earth. So when you say, gonna need half of that, thanks, you've just given it to us. So Flatzoid, it looks like you're in trouble once again. What do you got to say to that?
I'm a South African. You can clearly hear I'm a South African.
Diplomatic community. It's just been revoked.
Until next time, stay sensible.
Shut up and sit down.